Hi everyone. In this video, we shall see the topic analysis of variance. First, let us see what is design of experiments. Design of experiments is a systematic method to determine the relationship between factors affecting a process and output of that process. Basic principles of design of experiments. There are three basic principles. They are randomization, replication, and local control. Now let us see few important experimental designs. One is completely randomized design, which is otherwise called one-way classification. Next one is randomized block design, which is otherwise called two-way classification. And third one is Latin square design. So here we will see the working rule for one-way classification and a problem based on it. Now let us see what is analysis of variance, that is ANOVA. Analysis of variance is a statistical technique that is used to check if the means of two or more groups are significantly different. Working rule, that is for one-way classification. Set the null hypothesis H naught. There is no significant difference between rows or columns. Next, set the alternative hypothesis H1. That is, there is significant difference between rows or columns. Step 1. Find n, where n means number of observations. Step 2 is to find t, where t is the total value of observations. Step 3. Find the correction factor Cf, which is defined as t square by n. Step 4 is to calculate total sum of squares. TSS equal to sigma x1 square plus sigma x2 square plus etc. minus correction factor. Step 5 is column sum of squares, that is SSE equal to sigma x1 the whole square by n1 plus sigma x2 the whole square by n2 plus etc. minus correction factor. Here NA represents total number of observations in each column. Next we have to prepare the ANOVA table to calculate F ratio. First we have to find source of variation, that is between samples within samples. So here sum of degrees is to calculate SSE and SSE. Next one is degrees of freedom, that is k minus 1 and n minus k. Next we have to calculate mean square, that is MSE formula is SSE divided by k minus 1 and MSE, that is within sample. MSE formula is SSE divided by n minus k. So among this we have to find which one is a greater value. So depending on that, FC equal to among MSC and MSC, the greater value will be in the numerator and the smaller value will be in the denominator. Step 7 is to find the value using F distribution table. Step 8 conclusion, we have to compare the calculated value and table value. If the calculated value is smaller than the table value, then we accept null hypothesis. Suppose calculated value is greater than table value, then we reject the null hypothesis. Now let us see a problem based on this. A completely randomized design experiment within 10 plots and 3 treatments are given below. We have to analyze the treatment effects. So first, let us set the null hypothesis. That is, there is no significant difference between treatments. Next, set the alternative hypothesis H1. There is significant difference between treatments. Now we have rewritten the table value. So here the first vertical value, that is first column value is labeled as x1. Second column value is chosen as x2. Third column value is chosen as x3. So we have separated based on treatment A, B and C. So from this we have to find the total of x1, sum of x2, similarly sum of x3 values and also sum of squares of those corresponding xi's. Now step 1 is to find n. Here n is number of observations, so we have 10 values, so n is 10. Step 2, sum of all items, that is t. By adding up all the given data, we have the answer as 40. Step 3 is to find the correction factor Cf, which is t square by n, which is 160. Step 4 is to find TSS, which is equal to sigma x1 square plus sigma x2 square plus etc. minus Cf. So by substituting the values, we have the answer for TSS is 40. Step 5 is to calculate SSC, which is equal to sigma x1 square by n1 plus sigma x2 the whole square by n2 plus sigma x3 the whole square by n3 plus etc. minus correction factor. So by substituting the known values, we have SSC value is 6. Next step is to find MSE, that is mean square between samples. The answer is 3. Next, to find sum of squares within samples, that is SSE, which is equal to total sum of squares minus sum of squares between samples, that is 40 minus 6 is 34. Step 7 is mean sum of squares within samples, that is equal to sum of squares within samples by degrees of freedom, which is equal to 34 by 7, that is 4.87. Now let us form the ANOVA table. So here first source of variation is next sum of degrees, degrees of freedom, mean square and F ratio. So here sum of degrees, SSE value is 6, SSE value is 34. We know the formula for degrees of freedom, that is k minus 1. K value is 3, so we have 3 minus 1 is 2. Next n minus k, n value is 10, k value is 3, so n minus k value is 7. Now we have calculated the mean square values, that is we know the value for MSE is 3 and MSE is 4.86. So here MSE, that is mean square corresponding to within square is a greater value. So FC formula is MSE divided by MSC and the answer is 1.62. This is the calculated value. So here the degrees of freedom is 7,2 at 5% level. So we have the table value as 19.35 and now let us compare the table value with the calculated value. Our calculated value is 1.62 and table value is 19.35. So calculated value is smaller when compared to table value, so we accept the null hypothesis. There means our conclusion is there is no significant difference in treatment. Thank you.